Hi everybody, in this video we're going to be talking about how to solve exponential equations, and this time, unlike the second or so lesson that we had in this unit, last time we rewrote things in the same basis, and so we were looking at the numbers 3 and 9 and saying, oh, 9 is 3 squared, and so we can rewrite things, and that's all fine and dandy, but sometimes we're going to come across a point where 3 and 17 don't have anything in common, where I can't write 17 as 3 to a power. And so the question is, how do I solve for x? 3 raised to what power gives me 17? I know that 3 squared is 9, so 2 is not big enough. I know that 3 cubed is 27, so 3 is too big, so it's going to be somewhere between 2 and 3. And outside of guessing and checking, I'd really like an easy method in order to do this. So the first thing I'm going to do, and the process is the same in all of these problems, the first thing I'm going to do is I'm going to get the thing with the exponent by itself. Okay, so I see here that the 3 is already by itself. That's a perfect situation. The base of this equation is a 3. And so what I'm going to do is I'm going to take the logarithm of both sides with the base 3. Okay, I can do this as long as I do the same thing to both sides. I'm being fair and equal. It's like adding 2 to both sides, or subtracting 4, or dividing both sides by 3. I can take log base 3 of both sides. And the reason that I do that is because now you'll recognize that I have 3 to the x here. I'm saying 3 to what power gives me 3 to the x? Well, it turns out that the log base 3 and the 3 just go away. Okay? Here's another way to look at it. I'll write it out the first time, and then after this you'll see that you can just cross this out, in essence, is what we're going to do, and that's going to become just the exponent, x. Okay? But basically what I'm doing is I could think about it this way too. I could take the x and I could drop it down in front, and it's x of log 3 base 3. And then you'll remember from change of base formula, I can write that as log of the big number over log of the small number, and those go away, so that's equal to 1. So I really have x times a 1 is what's remaining over here. So I know it's a lot of chicken scratch there, but basically in essence what I'm going to do is, if 3 is the base, log base 3 of both sides gets rid of the base here and leaves me with just the exponent, which in this case is x. So x is equal to log base 3 of 17. On my calculator, I'm going to use change of base in order to find this. So I can use log or I can use ln. It doesn't really matter which. But I'm going to do log of 17 over log of 3, right? And so there's the answer. If I want in this format or this format, those would both be okay answers. But in decimal format, which is what you've been asked to do for your homework, that's because I want you to practice typing in the change of base. You can just do log of 17 in your parenthesis divided by log of 3 in the parenthesis, and the answer is 2.57, and it's 89, so I need to round it up to 579. Okay, that's the answer that I'm going to be looking for in your homework as a decimal answer. All right, let's do another example. 12 raised to some power is 1/3. And 1/3 and 12, I can't think of a number that both of them, go into. So what I'm going to do is the base is 12, so I'm going to do log base 12 of both sides. So log base 12 of 12 to the x is equal to log base 12 of 1/3. On the left-hand side, these go away, and I'm left with just an x. And on the right-hand side, it's the log of 1/3 over the log of 12 using the change of base formula. So I've got to be careful here. I want to get it to 3 decimals. I'm going to type in log of 1/3. I'm going to in the parenthesis divided by log of 12 in the parenthesis, and the answer is negative 0.4421. Because that's a 1, I can keep it as 0.442, right? So negative 0.442 is my answer here. By the way, easy to go back and check these things. Just say if I have 12 raised to the negative 0.442 power, I get about 1/3. And you can see that's rounded off, but that's what I'm trying to do here. Okay, what if I have e in a problem like this one? In this situation, what we're going to do is, remember that's a log base e, is what I'm looking for, which is a natural log. A natural log and e work against each other perfectly. And so I'm going to do natural log of both sides. That's the same thing, by the way. Remember, natural log is the same thing as log with the base of e. But in other words, what happens is those two go away, and x is just the natural log of 67. my calculator. That'll be pretty simple. Just type in natural log of 67. And it's 4.2046, so it looks like 0.205. X is 4.205. All right, so that's a basic start for these problems. Hopefully that gives you a good idea of what's going on here. And in the next video, I'll talk about a little bit more complicated problems in numbers 4 and 5, and then number 6 we'll get into a much different problem.